Okay, so now that you're pretty good at series circuits and at parallel circuits, it's time to spice things up a little bit. Because in reality, in your home, all those things that run on electricity in your home, they're not all hooked up either in series circuits or in parallel circuits. Most circuits have a section that's series and a section that's parallel. They have combinations of both. These circuits are often called combination circuits or complex circuits. Okay, and what we have to do to solve them is just a little bit more intricate than what we did to solve series and ones that were pure series or pure parallel. Actually, what you have to do, so here's an example. What you have to do is you have to simplify the circuit, the circuit that's complex, into either a pure series or a pure parallel before you can solve it. So when you look at a circuit, you have to figure out what sections are series and what sections are parallel. Well, the series section is the section where the current that leaves the power supply flows completely through that circuit. If there's a resistor that the total current flows through, then that resistor is in series. If the current splits and goes through several resistors, then those resistors are in parallel with each other. Okay, so R2 and R3 here are in parallel with each other, but they are in series with R1. Like together, they're in series with R1. So we could take out R2 and R3, and we could replace it with something that's called an equivalent resistor. A resistor that would have exactly the same value as these two that are in parallel if they were combined. So if we were to do that, our new circuit would still have R1 up here. And it would have, so this would be our R1 8 ohms. And this would now be called R2 3, because we've combined R2 and R3. And we have to combine it with what it's equal to, the equivalent. Remember when we were doing the first learning about series and parallel circuits, when I got to the R total, I said sometimes it's called the equivalent resistor because it's equivalent to one section. It's not the total of the whole thing. So the equivalent resistance, R2, 3, would be equal to 1 over R2 plus 1 over R3. And we can find that. 1 over 3 plus 1 over 6. See how nice I was to you? Common denominator would be 6. So 2 over 6 plus 1 over 6 is about 3 over 6, which reduces to 1/2. So 1 over R2, 3 is equal to 1/2 an ohm. So R2, 3 is equal to 2 ohms. So this is 2 ohms. Okay, the total hasn't changed. It's still 120 volts. And now I have a pure series circuit. Now I can solve. Okay, so once you've simplified it down to pure series or pure parallel, and this one's easy because it's only one step, but they will not all be this way. Then you're going to build a table, and if you've printed out the notes that I posted for you, the table's there for you, and you're going to fill in what you know. So we know V total is 120 volts. We know R1 is 8 ohms. We know R2 is 3 ohms. We know R3 is 6 ohms. And notice I've made a column for my new resistor, R2, 3, and it's 2 ohms. Okay? Now I can find my total R, because this is just in series, and so to find the total in series, you just add them up. So 2 plus 8 would be about 10 ohms, and that means I can now get my I total. It should be 12 amps. Okay, so first step, simplify the circuit until it's totally series or totally parallel, pure series, pure parallel. Find your R total. And then create your chart, and you should be able to then have all your R's and your totals. Now, to go to the next step, you look at your circuit, and your most simplified circuit. So you always start at the most simplified, and you say it's in series. And in series, what's the same? The current. So the current in this circuit is the same. So I total then should be equal to I1, 12 amps. But not these guys, not I2 and I3, because they're not in this simplified circuit. The only other thing in this simplified circuit is 2, 3. So I2, 3, there really is a 2 there, you just can't see it, should also be 12 amps. So now I can find V2, 3, it should be 24 volts. And I can find V1, it should be 96 volts. Remember, in series, the voltages should add up to give me back the total, and they do. Okay? Now, usually at this point, someone says, do we have to show all the work? No, I'm thinking you're going to be able to multiply 2 by 12 on your own. The only piece of work you have to show me are the R's, because if you screw up, it's usually the R's, and then I can follow you through it. Okay, so now we have to get these other two columns, and to do that, we have to take a step back to the less simplified circuit and say, well, R2 and R3 were in parallel. And in parallel, the voltage is the same. So V2 should be equal to V3, should be equal to the V that we replaced it with, V23. Because if it isn't, then I didn't replace well. So V23 will be equal to V2 and V3. And now I can find my I's. 24 divided by 3, 8 amps. 24 divided by 6, 4 amps. These two should add back together to give me 12, and they do, and I'm done. Easy, right? All right, example 2. I think I probably had a V total that I didn't write in here yet. V total is equal to 120 volts. Okay, so this time there's 4 resistors. And when you leave the battery and you follow the current, it would flow to this junction first and then split. That tells me that it's going to be a parallel circuit pure parallel once I simplify it. It splits, some of the current goes through this first branch, both through R3 and R4. They must be in series with each other then, and I could combine them. The rest of the current goes up here and it flows through R1 and R2. So they must be in series with each other because the same thing flows through both of them, so I can combine them. So my new circuit would look like this. Where this will be R3, 4, and this will be R1, 2. Now, I don't mind if you combine like 2 steps at the same time, as long as there's no resistors that are common. Like, I wouldn't want you to do like these 2 with something else. Like, you know, anyway, when we get to more complex ones, you'll understand. All right, I can find my R2, 1, 2. They're just in series with each other, so I just add them. This is 6 ohms. And R3 and 4 are in series. This is 12 ohms. And now when I look at my circuit, it is a pure parallel. So I don't have to simplify anymore. I can find my R total. It's just going to be 1 over R1, 2 plus 1 over R3, 4. Not 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. It's just these two. So that's going to be 1 over 6 plus 1 over 12. Again, look how nice I was. 2 over 12 plus 1 over 12 is 3 over 12, which is 1/4. So our total should be equal to 4 ohms. Then you would build your chart and fill it in. So V total, 120 volts. R total, we just found 4 ohms. R1, 4 ohms. R2, 2 ohms. R1, 2, 6 ohms. And I usually put my combined one right after what I've combined it with. So I combine 1 and 2 together, so I put my 1, 2 next. R3, 3 ohms. R4, 9 ohms. R3, 4, 12 ohms. And then I come back here and realize, hey, I can get my I total. It's 30 amps. And we're going to run out of time soon, and when we do, just see if you can finish this. Okay, so now we look at our most simplified circuit because we have all our I's and we have all our totals. Our most simplified circuit is in parallel. And in parallel, what's the same? The voltage. Which voltages will be 120 then? That's the question.